All right, welcome everyone to your first tutorial. So what we'll be doing today is we'll be going over just a brief introduction about the epidemiology unit per se, and then going into the details of your assessment items, which is of most importance, right? So in terms of the introduction to epidemiology, it is well covered in the slides or in the YouTube videos which I had provided to you. I hope you have had an opportunity to go through them. And if not, please go through the YouTube videos before you go through this recording. All right, so please check out the YouTube videos. They are pretty short, they are fun, very animated, and trust me, they are not boring. All right, so yes, we'll be having a very brief overview regarding what is epidemiology, because you must have seen in the lectures, I directly go into the content. So over here, I'll give you a brief overview, and then we'll be going more into the assessment items and things like that. All right, so moving further. All right, so yes, just a little overview about me before we move on further. I'll just shift my camera position because I need to read what's there on the slide. Okay, so yes, as I have said previously, that my name is Dr. Rati Jani and I'll be convening your unit. What I have done is I have done my PhD in nutrition and dietetics. I'm an advanced accredited practicing dietitian. So I'm affiliated with the Dietitian Association of Australia. And I did my PhD from Queensland University of Technology in Brisbane. I did my dietetic degree, like how most of you must be doing your masters in various fields. So I did my masters from Griffith University at Gold Coast in dietetics. And so after my clinical master's degree, PhD, after PhD, I did around 4 years of postdoc. So my postdoctoral fellowship were 2 years in India, 1 year in Atlanta, United States, Emory University, and then my final year at Western Sydney University in Sydney. And it was pretty fun because I have worked across a lot of topics. Say, I have worked in the area of malnutrition in India, which is undernutrition predominantly. In the United States, I worked in the area of nutrition genetics. Then within Sydney, I worked in the area of diabetes prevention and management. And my PhD was in the area of childhood obesity and children's eating disorder, particularly picky eating, fussy eating. And currently, as an academician at University of Canberra, I'm carry forwarding my PhD research after so many years, which is I'm looking into the genetic and the environmental causes of picky fussy eating among children. So that's my current area of research. So yes, originally I'm from India and therefore the accent, and I hope you can understand. So I think you shouldn't be having a problem because Australia is pretty multicultural. Right, so yes, so from India I did my bachelor's and my first master's, which was in food science, whereas my second master's in Australia was in clinical nutrition. So yes, it's been around 10 years that I've been working, researching, and I came to UC 3 years back. So it's been 3 years in UC now, and I'm very big into quantitative research. Say advanced statistics is my forte. For instance, structural equation modeling, confirmatory factor analysis, things like that, modeling techniques which you use for validation of questionnaires and things. So I love doing all of that. And therefore, I'm teaching you this unit is because I love quantitative research. I do a lot of quantitative research. And to do statistics well, you need to have your epidemiology very, very strong. And therefore, the confidence with this unit is because, yes, when you have learned a lot yourself and you have studied this yourself and you have applied it in practice, then you become pretty knowledgeable, not just theoretical wise, but even practice wise within what you teach. So yes, therefore I'm convening this unit. Although I'm a dietitian, I'm a quantitative researcher and doing a lot of advanced statistics. So therefore the unit. So basically, if I have to sum up epi you can say is sort of the theoretical background which you need before you start doing research. So for instance, as a student, I did my epi unit first. Then I did units such as research planning, quantitative research, qualitative research, and then you further. But epi, say, is the foundation of research. And therefore, all of you are doing it as well. All right. So yes, because generally this unit is going to be flexible in the future when I teach it in the second semester next year onwards, meaning the lectures will be online, they will be recorded, but the tutorials will be face to face. That's how it will be convened. But this year, because of COVID, I'm keeping everything online, and a lot of students, they have requested this as well because of their work secondary to COVID, which has been impacted, odd work hours. So I thought that might as well keep everything online recorded. So it's useful this year, and hopefully it causes you all minimal inconvenience. All right, so yes, the best way to reach me, because this is an online unit, is via email. All right, so please do allow a few working days, but generally I respond very fast, so you won't have complaints in that area. Okay, so yes, that's a bit about me in a nutshell, and now moving forward. Okay, so now what is epidemiology? So epidemiology, as defined by the researcher, is the study of the distribution and determinants of health-related states or events in specified population, and the application of this study to the prevention and control of health problems. Now, does that make sense to you? No, right? Because if I were studying the unit as a student, and for the very first time, if I had to read this definition, I would be completely overwhelmed. It would not make sense to me. Obviously, it makes sense to me now because after spending 10 years of research, it automatically makes sense to you. So what I have done is to give you a broad overview about what epi is. I have broken down this definition into something which is logical, which you can understand, which is reasonable. Okay, so let's go through my concept of what epidemiology is. All right, so you have two very important people in epidemiology. All right, these two important people are called as John Snow, who is the father of epidemiology. And from the YouTube videos, you will now know why he is the father of epidemiology, because he was the first one to identify the association between fecal contaminated water causes cholera, big epidemiological outbreak. So yes, he's considered the father of epidemiology. Who was his sidekick? His sidekick is William Farr, all right? And yes, he is the indispensable sidekick, all right? So he was the one to carry forward John Snow's work, and say he was the one to then start the big sanitation movement, trigger the sanitation movement, and because of which now we all have pure non-contaminated water to drink, and therefore now we all are not dying of cholera. Okay, so yes, basically these two people are the pioneers, the leaders of epidemiology. All right, so this is my version of how they look, Batman and Robin, but how do they really look? So this is how they really look. And as I said, don't judge a book by its cover, but it is their contribution to the field is what we should respect and acknowledge. And they may be pretty fashionable during their era, like who knows, okay? But yes, these are pretty cool people in epidemiology, and this is what our epidemiology, the unit, is based on. It's because of them we are studying this unit as a science. Okay, so moving further. So now what is epidemiology? The investigation process. If you have seen these YouTube videos, all of this will make sense to you. The investigation process which was undertaken to fight cholera. What is cholera? Cholera is the problem, all right? That's our problem, which is people are dying because of this disease condition called cholera. So the investigation process undertaken to fight cholera, okay, you get the message, right? Yeah. So that is epidemiology. Now, what do I mean by investigation process? We'll go into details of that. Okay. So when I say investigation process, there are a couple of key questions that you need to ask to do an investigation. As the name suggests, investigation meaning you need to ask the right questions. So what are the right questions as an epidemiologist that you should ask for any sort of problem? So for example, when I teach you about this in terms of cholera, because that's the example which I'm using as the John Snow example, but the biggest outbreak, which is not even an epidemic, a pandemic that we have is COVID, right? So think of these things in terms of COVID and see if you can answer these same questions if you were thinking of the problem COVID, all right? So now I'll explain this in form of, as I said, the corolla example. So what is the disease? The first question, what? Whenever you talk about what is the disease, it means you're talking about the problem, all right? What's our problem? What is the disease condition? It is corolla, all right? Corolla. Anyways, who is the disease affecting? Meaning, who is our target population? It is people drinking water which is contaminated with fecal matter. Okay, so those people are our problem. Okay, not people anywhere and everywhere, but those people who have drank contaminated fecal water, they are our target population, and the disease is affecting those individuals. So those are our who. Okay, now where do these people live? Meaning the place. They live around water sources which are contaminated because of fecal matter. So you must have seen in those YouTube videos where Jon Snow has clearly seen those individuals who are around, say, the water pipe, the community pipe which was there. That was the area which had the most corolla outbreak. All right, so that's the one. Then when did the people become sick? Which is the time. So after drinking the contaminated water, they became sick. Why did the people become sick? Now, when we talk about why, we are talking about in terms of significance. Okay, why meaning the cause. And now we know why did they become sick? They became sick because they were suffering from cholera, which is a waterborne disease, a waterborne infectious disease, which has spread because of drinking contaminated fecal water. All right. Now, what will happen if the disease is not addressed or cured, or yes, if you don't find a solution for it, meaning we are talking about the consequence. What will happen, meaning in terms of consequence. So yes, there's going to be a lot of morbidity and mortality. Morbidity meaning sickness, which will eventually lead to mortality for a lot of people. All right. Then how can you stop people from becoming ill? So what's the solution? Stop drinking contaminated water. That's the first thing. All right. And then in the long run, the long-term solution is the sanitation movement. So you can answer all of these questions, guys, if you were thinking about COVID for the 2020 example. Okay. So think about COVID and try answering all of these questions. This is what an epidemiologist does, which is the investigation process is called epidemiology. You're asking what, who, where, when, why, what in terms of consequences, and how. Okay, so these are the key questions that an epidemiologist answers. All right, and these are very important. The middle column, which you have problem, target population, place, time, significance, significance in terms of causes and consequences, and finally solution. So this is like the entire package of what epidemiology is. Okay, so now moving forward. So now, what are the key epidemiology steps that Jon Snow undertook to discover that cholera is a waterborne disease, and then the solution to the problem, which is sanitation? Sorry, I need to keep moving my video to read the statement. Okay, that's why the hiccups. So yes, so basically, in scientific terms, what did Jon Snow do to identify that cholera is the problem by which people are dying, and the solution to this is the sanitation movement, meaning for people to stop drinking water which is contaminated with feces. Okay, so what he did firstly was he identified a correlation. What did he identify a correlation between? Drinking of contaminated water resulting in cholera. So this is called as a correlation. So now when I put my statistics hat on, which I'll do a lot in this unit, and you may be tired of it, but oh well, you'll just have to deal with it, right? So now when I think about this, how would I do this statistically? I would use something as simple as Pearson's correlation or Spearman's correlation if my data was non-parametric. I can't go more into stats because this is not quantitative research, but basically, if you had to identify correlation in real life, in practice, you would use a statistical test, something like Pearson's correlation, to see whether those individuals who have drank contaminated water, are they suffering from cholera or corolla? All right. So basically, I would do a Pearson's correlation for it. All right. Then if you find a significant correlation, meaning P is less than 0.05, okay, then you would see, is it right to say whether drinking contaminated water causes the disease condition? All right, I'll just call it a disease condition, guys, because I don't know why suddenly I've forgotten how to pronounce corella. Anyways, okay, so suddenly these things happen to me. Anyways, but my science is always right, so rest assured. Okay, so yes, so the causation. So the first thing always to do in real life evidence-based research and practices, first see, are these two things correlated? If they are correlated, then you can think about whether there is a causation between them. Okay, because causation is much more stronger, guys. Only if things are correlated, then it makes sense to investigate further to see whether A is causing B. Okay, so now how do you identify causation? Well, in real life, study design, a type of study design helps you to identify causation, not just a statistical test. Okay, so you may have a sample size of say 100 million people, but that doesn't give you sufficient grounds to say X causes B. Okay, to use the word causation, it all depends a lot on the study design. We'll be talking more about this when we go into our lectures further on in the semester. But basically, what type of study designs today are acknowledged or can give you the validity of using the word causation? Randomized controlled trials. Okay, did Jon Snow do randomized controlled trial? Hell no. Okay, why? Because it was not practical for him. People were practically dying of an endemic, and there was, the science was not that advanced. But if you see now, look at the difference, guys, is now when we have COVID, there are so many countries who are doing an RCT trial to identify a vaccine for COVID, right? For the coronavirus. That is the difference. At that time, Jon Snow didn't have all of this sciences together and everything was not robust. So what did he do? He first started basically with case studies. Case studies meaning, you know how in the videos it was said, he went to patient, one patient to the other patient, tried to record their history, tried to see what's happening. From case study, then he went to say observational studies. He started looking at communities, at neighborhoods, and what are the patterns between communities which are having the disease condition versus those that are not having the disease condition. Then he went on to more case control sort of an experiment where you saw that there was say line A and line B. Line A was receiving water from a contaminated source. Line B neighborhood, meaning the houses which were situated on this side, they were receiving water from the non-contaminated source. Therefore, line A, everybody died. Okay. So basically, yes, a type of study design helps you to identify causation, which, as I said, in today's world is only possible via randomized controlled trial. And there are different types of randomized controlled trial and all, but that's more quantitative statistics. Okay. So then what he did was he also used the tools of clinical epidemiology. So if you say the best tool for clinical epidemiology, as I said, is a randomized controlled clinical trial, which is what we are doing for corona, all right? But for clinical epidemiology at that time, for instance, he took a few samples of contaminated water sources, non-contaminated, identified what's the difference. And of course, he found that there were fecal matter and that is what was causing the disease outbreak at that time. Okay, so yes, he used a few clinical epidemiology techniques into this. But as I said, the gold technique for causation today is randomized controlled trial. All right. So I hope this is making more sense as to what epidemiology is rather than the black and white definition in the first slide. Okay. So yes, moving forward. So what are the key epidemiology steps that Jon Snow took to identify that there is a correlation between, say, the disease outbreak and the solution? What is needed was sanitation. So it is very important, guys, in epidemiology to keep in mind what is the research question. All right. When I talk about research question, you need to have an independent variable and a dependent variable, meaning a exposure and an outcome. All right. What is our independent variable in this example? Contaminated water, fecal contaminated water. Okay, that's our exposure, all right, which is our independent variable. What is the contaminated water causing? When you answer this question, that makes the other end of the thing the dependent variable or the outcome. Which over here is your disease condition? Corolla. Corolla. Okay. All right. So basically, guys, why am I stressing on this is because throughout my career, I have seen students get absolutely a lot confused between what is your IV and what is your DV. Answer this question. What is causing what? If you can answer this, then you will come to know. So contaminated water, drinking contaminated water is causing a disease condition, meaning the disease condition is your dependent variable, the outcome. So that is important. That is what I mean by John Snow kept in mind his key research question. What is the exposure? What is the outcome? Okay. Then he tried to identify, is the correlation between the disease condition and the exposure just a chance, or is it a cause? So as I said, a correlation could be a chance. Okay, it may just happen once and not later. For you to say that X is causing Y, further investigation is needed. For example, today we know that smoking is one of the biggest causes of cancer, all right? For example, lung cancer, right? So over here, to say that smoking causes cancer, a lot of randomized control trials were done across the world, and a lot of these studies showed the same result. And therefore today now we have level 1 evidence to show that smoking is a cause of cancer. So to use the word cause, you need a lot of further investigation. So the first thing which John Snow kept in mind was, is this correlation between contaminated water and the outcome just a matter of chance, or is it actually causing the disease condition, drinking contaminated water? Then he investigated, are there any biases? Meaning, is it that the disease condition or is only affecting the poor, or is it only affecting the, say, illiterate population, or is it only affecting a particular ethnic background? All right, so these are the kind of biases he investigated further. And then lastly, he saw, are there any confounders? Meaning, is it like, for instance, even among the poor population or low economic strata of the society, only those who are drinking contaminated water are dying? Of course, yes, that was what was proven. But these are the kind of things they investigated, meaning there are key 3 things which are very important in epidemiology. First, is it just a chance or is it a cause? And you can investigate this statistically. Are there any biases? Again, you can investigate this statistically. It's like epidemiology and quantitative research are like best friends. Okay, it's like 2 sides of the same coin. They're like buddies. Okay, you can't do one without the other. All right, and lastly, you can also investigate statistically, and you can do this a lot with your study design as well. Are there any confounders? Okay, so what was the conclusion at the end which John Snow came to? That yes, individuals of low strata of the society, meaning the people who were economically disadvantaged, so yes, they were a high risk population. Why? Because they were having a lot more, say, outbreaks of the disease condition. Why? Because of the sanitation around their places, the water source coming through their houses. All right, so yes, they were at high risk. And then, but the biggest thing was, it was not that all poor people, for example, I'm just using layman terms so it's easier for you to understand. It was not that all poor people were dying because of cholera, but it was those individuals who were drinking contaminated water. And then if you go by this theory, rich were also not spared. But of course, but if you see, the outbreak was more predominant among the lower economic strata of the society, which is but obvious because of the hygiene sanitation condition not optimum where the lower economic strata of the society is based in. All right. And yes, so the confounder over here was contaminated water, The bias over here was that yes, individuals who are poor, they were at a high risk population, not that rich people did not have the risk. Mind you, they were just at a higher risk population. And all of this together led to mortality secondary to the cholera outbreak. All right, so basically, chance cause bias confounders. We'll be going through the theories of all of this also in your lectures, but again, with those key investigative questions which you have to keep in mind for epidemiology, these three things are very, very important in epi as well. The ones which I have discussed over here, and we'll be looking at them in detail when we talk about it in the lectures. All right, so I really hope you are following this, guys, and this technique of teaching is helping you. Please let me know. All right, so give me your feedback over emails, give me your feedback over the discussion board, which I'll show you that I have made. So I can know that you're following it and you're comfortable with my teaching style, and it's you're registering it. Okay, it's not like going over the top. We don't want that. All right, I want you to really understand this unit, and hopefully for a lot of you, it will be applicable in your real life and research as well. Okay, so yes, what's the conclusion? Conclusion is that when you learn epidemiology, you become a scientific detective. All right, not just any detective, you become a scientific detective because you have the best evidence to show why something is causing something. All right, so yes, let's all go into the journey of becoming scientific detectives. What's happening to me? I've been recording a lot of online lectures. I can feel it now.